Okay, good afternoon to everybody. In the meantime, I present myself. I'm Monica Palmirani from University of Bologna, and today we try to have a talk concerning the blockchain, smart contract, and distributed technology ledger. And you can see my slides, I guess. In case you're not, please raise your hand. And
we
you can
see it.
Yeah, okay, super. So before to leave the floor to the panelists, let me introduce a little bit the topic. I'm coordinating a laboratory in the University of Bologna in the CSFID Center called the Legal Blockchain Lab, with the goal to make prototypes and investigate application not limited to the financial domain, but applicable in the legal domain. So the blockchain technology is not a new technology, started in 2008, more or less, to talking about, or also before. But during these years, we assisted to the application in the financial sector, especially in cryptocurrency domain. But in the last 2 years, we can see also application in different domains in respect to the fintech. And today we want to investigate a little bit those applications beyond the financial application. So just for give some definition, for distributed technology ledger, we means a decentralized architecture of nodes connected each other, so like a repository distributed, but without centralization, with some characteristic guaranteed, like integrity, security, and legal validity of the information events stored inside of these distributed register ledger over the world. Another very important characteristic is the transparency of the events recorded inside, and all the mechanism is based on an algorithm called the consensus algorithm. So the governance of these mechanism is in the hand of some programmers over the world, or mining people. So it's very important to put attention of these consensus algorithms. It's important also to distinguish, like you can see in the boxes, four kinds of blockchain or distributed technology ledger: public and private. Public means that everybody can read and write and comment, and private, that is not for everyone. And permissionless means without authentication of the people that can participate inside, and permissioned means with an authentication. And the cross of those two different characteristics, four in total, divide the market in three main possibilities. One is useless, like private and permissionless, and not possible, feasible. But the other three is a topic, a hot topic in the community concerning these technology. And just for your knowledge, private and permissioned is the current offer in the market by commercial companies that provide a private, so closed, decentralized nodes for this technology, and with permissioned people, so people that need to be authenticated before entering inside of the network of the nodes. So IBM and others produce a lot of application for the market nowadays, used in different domains. And I would like to stress this point in the Deloitte report, just very close and new, that this is a market nowadays covered by this technology that is growing up, not limited to the financial tech services that are in more or less in the bottom. So now the most emerging topic and domain in the market is concerning media, telecommunication, energy, environment, Internet of Things, supply chain, and healthcare, and finally also the professional service. So today we want to focus the attention of the legal application for legal practitioners, how it is good for in this perspective. So I would like also to say that there is a project in Europe for building a distributed infrastructure of blockchain with the main actors of the member states in order to compete in the market with the US and China. So this is a very good news in order to have decentralized, scalable, open, sustainable, interoperable infrastructure at the European level without to depend to external actors. And nowadays we have in this project 4 pilot cases with the involvement of 19 member states. And this is more like the infrastructure. So in order to have a basic instrument of these infrastructures and use case in the top, and also business application in order to involve also private sector, not limited to public organization, but also private sector. And this European blockchain partnership is very important for promoting the market in the future. And these are the 4 pilot cases. The diplomas is a very good topic and domain where to experiment the interconnection and the notification between different countries. So the possibility to have interoperable application between member states. And what is used for? I recommend you this report that is made by the European Commission. And you can see inside of this report some example of application for anti-corruption, anti-money laundering, identity management using blockchain, of privacy tools for protecting data protection, IPR and patent protection, supply chain in private and public sector, e-health database, biobank protected by blockchain, e-government using smart contract, voting, e-documentation, and Internet of Things. You can see the report here. And finally, this is the emerging project funded by the European Commission in the last Horizon 2020. And you can see that the financial sector is not in the top. So you can see Internet of Things also, and the cybersecurity in general are using this kind of technologies. So now I leave, after this brief introduction, the floor to the next panelist. And in particular to Biagio Distefano, that is a PhD student in the program Law, Science and Technology. So the floor is yours, Biagio.
Thank you, Professor. Thank you for your introduction. I hope everybody can hear me. So I will start my presentation without further ado. I hope you can see my screen. Very good. So yes, let's start.
We can.
Perfect. So as Professor Palmirani said, my name is Biagio Distefano, and I am a PhD candidate in 2020 degree Law Science Technology Joint Doctorate. And today I'm going to present to you a project that I developed together with my colleagues Nadia Poker and Mirko Zeggigi. What was the goal of this project? The goal of this project was to implement a decentralized model of governance, a model of governance where all parties are peers, where no governing bodies are formed, where all the roles of this group of people are fluid, and where participants are incentivized to uphold the rules that they give themselves. And also, the objective of this project is to build a governance mechanism that allows to reach a consensus. And of course, we need the ability to enforce decisions. So let's take the problem scenario that we encountered. Basically, we have a group of people that decide to abide by a certain set of rules. So what do? We are all lawyers, almost all of us are lawyers. We stipulate a contract, thus formalizing. Then we decided that there should be no hierarchy between us. All the parties are peers. However, the violations of the rules that we impose ourselves need to be recorded in a transparent fashion, and violators need to be dealt with and face the consequences of their violations. So there is the need of a dispute resolution system, and also, most importantly, the governance needs to be seamless. How do we achieve all this? Thanks to the technology that Professor Palmirani introduced earlier. Basically, we created a game. We use a technical gamification. So we took the problem and we made a game out of it so we could involve all of our colleagues. And this experiment is actually still ongoing. So we've been using this app we built for several months now, and we're still using it. And I'm about to talk about it. So, ModCoin. This is our experiment. ModCoin is basically a game of forbidden words. These are the rules that we thought. Some work-related keywords are forbidden outside of the office premises. And since we are all law and technology researchers, these keywords, of course, are big data, blockchain, artificial intelligence, privacy, etc. Now, if someone says one of these keywords outside of the office, they have to pay the penalty. And the penalty is, of course, to buy a beer. There are, of course, problems. There are 20 of us. So who is going to police? And how do we incentivize people to participate? Avoid cheating? How do we handle dispute resolution? How do we keep track in a fair and transparent way? Remember, there are no governing bodies. There is no hierarchy between us. And this is a key point. So what we did was build a bot into our chat. Each of the candidates can sign up contacting a Telegram bot. And upon signing up, they're getting 20 tokens to start playing. If someone says a forbidden word outside of the office, another candidate has to accuse them. And the accusation can only happen in the group for transparency reasons. The accusation is stored on the blockchain. The accusation costs 1 token that the user has to put a stake on the accused candidate. Now, after the accusation occurs, the accused candidate has 2 choices. He or she can either buy a beer to another candidate, or he or she can challenge the accusation. If he chooses to buy the beer, a different candidate has to testify in the group chat, a different candidate from the accuser and a different candidate from the accused candidate. Now, this action, of course, is stored on the blockchain. The stake token is returned to the accuser, and reward token are issued to the. However, if the accused chooses to challenge the accusation, the stake gets lost. A trial is opened, the challenge is stored and open on the blockchain, and a poll is created on the group chat. The accused is now a defendant. Each candidate can now cast their vote on the group chat's poll and decide on the verdict. The vote is stored, of course, on the blockchain, and each vote weighs as much as the number of tokens they have. At the end of the voting window, the sentence gets executed. Now, of course, if the defendant is found guilty, the stake gets imposed, and they will have to buy the beer. If the defendant is found not guilty, the accuser loses the stake, and the stake is removed from the blockchain, and the defendant will not have to buy the beer. Now, of course, what I've just shown you is a simple game. You have to picture that you can create any kind of set of rules that you have to uphold. We chose to make a game out of it because in this way it would have been easier as it was to involve all of our colleagues. But the rules can be anything, and the penalty can be anything, of course. Now, it's way simpler if I show you the actual interface of this project, which is, as I told you, on our group chat. As you can see, inside our chat, somebody can just invoke the bot and accuse a candidate of saying a word, as you can see by the first message that I static using L. Now, what Modbot will do is store this action on the blockchain and show us the transaction hash on the blockchain. This is happening on the Ethereum blockchain, specifically on the testnet Ropsten. Now, in this case, Alice decides to challenge the accusation, saying that it is not true that she said a forbidden word. So the bot will spawn a poll that will serve as a voting mechanism to settle the dispute. Once everybody has voted or window closes, the sentence gets auto-executed. And everybody can check the trial on Etherscan via the transaction hash that Modbot provides. On the other hand, if someone pays the debt, as I already told you, another candidate, in this case Alice, can testify that Bob paid here. As you can see, Modbot will store the action on the blockchain, and reward token will be issued. Now, this is, of course, really simple. And this is a screenshot of one of the transactions that you can find on Ropsten. Now, of course, this is a really simple scenario that I proposed, but it helps us to showcase some of the technological and legal issues that we're facing whenever we encounter a decentralized application, and more specifically, a smart contract-based application. So I'll try to be quick, but let's go over the technical insight and why this matters. So for the tech people there, what we use to develop this from the blockchain point, we use the Pragma 0.5.3. Basically, it is a custom ERC20 token. We use truffle and for development while we deployed for production on Ropsten testnet. For what concerns the interface, we decided to use Python for writing the bot and a small server application that handles some of the messages, and PostgreSQL for production, while SQLite 3 was used. But why am I telling you this? Why does this matter? Why does the architecture of this simple application matter? It matters because we have to question, whenever we encounter a decentralized application, what is the actual level of decentralization of this application? Where does the power, the decision power, really stand? So we have to find out what are the problems and what possible solution be. So let's talk about more. First question: how decentralized is it actually? Now, as I said before, in order to play, you need to get mod coins. You have two possibilities. Either you get them from someone you know sends you some of their mod coins. So this is not completely decentralized, because whoever controls Modbot basically controls the token that can be issued for you to begin playing, for you to start playing. So this is actually a semi-permission ecosystem built on top of a permissionless blockchain, because we're building this on top of Ethereum, which is permissionless. But our smart contract is not entirely open. It is a semi-permission system. Semi-permission because you either have to contact Modbot, which we control, or a person you know can just simply send you coin and then you can start playing. So it's not entirely permission, but it's not entirely permissionless. Another key aspect of this application is that Modbot controls your private key, which is your wallet. This means that Modbot will perform on your behalf every action. This being staking on someone, accusing, testifying on someone, voting, sending mod coins, sending Ether, or whatever. So when using this app, then you are not truly the owner of your tokens. The app is just a service that you use to access the blockchain. Theoretically, we that develop these applications strip you users of all of your tokens. Now, so who built it? This is a really important question. Now, of course, we built it. It is an open source by default, but is it? Because it is stored in the blockchain. I mean, you write the code, but does it mean that this makes you trust us More, if you are not a programmer, you will of course have to trust us that tell you that that code does exactly what we claim it does. And does this matter? Of course, yes. So the main question is now, how do we know that the smart contracts code reflects faithfully what we agreed upon off-chain? As of now, we really don't. You have to trust us. You have to trust the coders. And this is a problem. We need a way for a quick, formal, logically sound legal validation of contracts provisions against the smart contract code. If we do not do this, there is no point in using smart contracts and then claiming that we are in a trustless ecosystem, because you will have to trust the code. So how can we achieve this? Well, of course, one possible solution would be to use a command total, legal ontologies, and legal rule ML, and combine this technology to build something that is called an intelligible contract. Now, I will not go deep into this because this is the work of Luca Cervone, my colleague. But the key idea is to basically bridge the gap between the human readable, the lawyer readable contract and the smart contract in a way such as that the provisions of the smart contract can be read against of the lawyer readable contract. Now, okay, but what is Modcoin? So technically speaking, Modcoin is a custom ERC20 token with some peculiar rules of minting. The players, the parties of the contract, if you prefer, serve as some sort of oracles, but they're not quite oracles because they do not have their own smart contract. They just input data into a smart contract. They input violations and payment. So it is kind of similar to a decentralized autonomous organization, but it is not, technically speaking, because there's no ether for tokens exchange. And most importantly, now the voting system is democratic, it is rather meritocratic, and there is no way of increasing the coin amount if not by playing by the game rules. Of course, this incentivizes a participant to abide by the rules, because if they don't, they lose tokens. And most importantly, the vote is not secret and cannot technically be. So basically, Modcoin is a kind of hybrid between an ERC20 token and a proper decentralized autonomous organization. And we will see why this matters. But is a contract, legally speaking? Is Modcoin a contract? Well, being Yoshi Causa, meaning being it developed for fun, basically, it is not exactly. But what if it were not Yoshi Causa? What if the rules were not just simply saying a forbidden word and buying a beer? What if it was a real contract? Well, in our case, but this applies to most cases, the agreement was formed between the participants before the smart contract was coded and deployed on the blockchain. In this case, it would be safe to argue that Modcoin is not a contract by itself. Modcoin is just a tool that we use to track transparently and permanently the events that are relevant to the contract in the real world. This aspect, because most real world applications fall within this classification, meaning that in most use cases, there will be a legally binding contract that precedes the smart contract that is going to be coded. Does it matter? Well, yes, it does, because the smart contract dwells in a decentralized environment. There are many issues that can arise, such as what jurisdiction do we apply? What law do we apply? Who's liable for bugs or security flaws? Consider that there is no central authority, there is no central node, there is no central server. So for the argument's sake, let's say that Modcoin is a proper contract. So let's say that none of us knew each other beforehand, that we all lived in different parts of the world, and we decided to, based solely and entirely on the smart contract source code. Like, for instance, argue happened with CryptoKitties. So theoretically, smart are made in a way that should prevent litigation, because everything happens everything happens on the code, everything is auto-executed. And some also say that the code is the contract itself, which is the point that I'm trying to make here. with all its rules and eventual bug. Still, there is a huge margin of disagreement. Any of you that are savvy of blockchain know the DAO hack proved that there can be disagreement on the content of a smart contract that can cause, as it was in this case, a hard fork. Plus, people like to sue. So we have to bring back some of the previous questions. So I will go quick on this because these are not answered.
Conclusion.
Yeah, I'll go very quick. So as you can imagine, a jurisdiction problem. So we have to ask ourselves if we can apply the EU regulation on jurisdiction. This seems not to be the case because it's most importantly, we have also to ask ourselves if apply the Convention on the Recognition and Enforcement of Foreign Arbitral Awards, what concerns the dispute resolution mechanism. I don't have the answer of this for this, but this is a key question. So does the dispute resolution system fall within the scheme of an arbitration? What is the applicable law? Well, this is kind of easier, and a plain reading of the European regulation, if we're all in Europe, of course, should answer this question. And I will just skip this slide, and I have no time. And finally, and in conclusion, the main problem is what and whose liability? Should the developer of this open source software be considered fiduciaries? Are they responsible for bugs and security flaws? How can we know if they have to be considered fiduciaries? Of course, we can use Tamar Frankel's theory, so they do hold a certain amount of power. But deciding to consider software, in particular open source software developers as fiduciaries, has some pros and cons. Very briefly, the pros are that if I am an open source developer and I decide to develop a project, knowing that I can be liable for what I do, I will be more careful in coding. On the other hand, it could inhibit innovation. If I'm afraid that I made a mistake and the project is huge scale, I will be thinking twice before pushing a code. Now, I will wrap this up because my time is done.
Yes.
So I thank you for your attention, and I hope you enjoy the presentation.
Okay, thank you so much. I suggested to maintain the time for the question at the hand in order to have a slot dedicated to the answer, question and answering. So now we pass to the next speaker, Andrea D'Intino from Dyne is a company. Andrea, are you in the chat? Yes, thank you so much for coming. So please, the floor is yours. Present yourself and go ahead.
Good afternoon, everybody. Okay, very briefly, we worked together. I had the pleasure and the honor to work together with Monica in the Decode project, which was an Horizon 2020 project that got flagship status. It ended last year in the end of November, and the fruit of the output of our collaboration was a paper where we explored the possibility to link together our smart contract engine with legal ontologies, which is what Monica showed us. So today I will talk to you about our smart contract executor called Zenroom. I have 4 slides that we're going to go through them very quickly. Then I'm going to do a super fast hands-on demo. So I hope I won't take too much time. All right. F5. So you should be able to see my screen in full screen right now.
We can see.
Okay. Perfect. So the tool is called Zenroom. If to all of you are curious, you want to run ahead, you just go on zenroom.org and you'll find most of the information I'm telling you about. We call it Crypto Smart Contract Executor. Until a few weeks ago, the punchline on the website was Crypto VM, where VM stands for virtual machine. in the sense of Java, not in the sense of VirtualBox and yeah, and the virtual machines you run machines inside, let's say. Because of that, we changed our punchline to something that was easier to understand and less confusing. So we call it Crypto Smart Contract Executor for database and blockchain. The gentleman who spoke before me mentioned the Ethereum smart contract system called Solidity. We do also execute smart contract, but with a very different language than the one used in Ethereum. And I'm going to show that in a minute. So how do I go forward? Here we go. Yes. Okay. What is Zenroom? Really in a nutshell, Zenroom is written entirely in C. Well, actually, half of it is written in C, and half of it is written in Lua, but Lua gets interpreted in C. So the executable is entirely compiled from C, meaning NCC 99. The payload for most platforms is around 1 meg, and you can perform simple operations in as little as 200 kilobytes of RAM. It does most complex cryptography in around a meg of RAM. So with 500 Ks of RAM, you can do quite a lot of cryptography and script execution. We have builds for most platforms you can think of. So Linux, Windows, macOS, Android, iOS, and WASM. WASM gives us a major competitive edge because to those of you who have never heard of it, WASM is a new emerging standard in W3C. It is a compiled language that is executed in the browser, exactly like JavaScript, but unlike JavaScript, is a very, very low-level code. So WASM stands for Web Assembly. It's rumored that the next generations of video game engines will run mostly on WASM, and we can tell you that when it comes to Zenroom, some functionalities are faster in the native code, and some are faster in WASM. So basically, we can run a script or a smart contract, and the script will run exactly the same way if you run it natively or you run it in a browser. Okay, and we also have binders for different programming languages. I believe the most interesting feature for the audience is the fact that the Zenroom can execute smart contracts written in Lua, as well as in our domain, in our own domain-specific language that was developed together with Zenroom. Is inspired by BDD, which stands for Behavioral Driven Development. The syntax is close to Gherkin. And we like to say that the language you can script Zenroom in is English-like. We don't want to use the term natural language because the syntax is rather stiff. You can't really change the order or the setup of a sentence, but the language reads pretty much like English. The goal of this was to develop a scripting language that could be, first of all, read by non-programmers, so by people with no programming skills, as well as written by people with no programming skills. And in a few minutes, I'm going to give you an example. Selected features. So until now, I told you what Zenroom does. Sorry, until now I told you how Zenroom is built technically. Now I'm going to tell you what it does. 3 features above all. First of all, it can do fully deterministic end-to-end encryption, meaning that you can have an application, a mobile application on your phone, on Android, and you can encrypt data, and then you can decrypt the data in the browser without anyone being able to read what's in between. So without going through the usual encryption channel like SSL. Symmetric, point number 2, symmetric and asymmetric cryptography, including zero-knowledge proof and ZK-SNARKs. Those are terms that are very trendy right now in blockchain. Zero knowledge proof is a way to use a certificate to prove a certain attribute instead of showing the attribute. To give you a very quick example, if you have to purchase alcohol somewhere, instead of showing your ID card, you would show a certificate produced by a trusted authority that certifies that you're above 18 years old of age. This goes, by the way, beyond the usual certificate that some of you might be familiar with, like, for example, X509 used to issue SSL certificate for the web, because you can use this kind of cryptography in a blockchain. As we see in the ZK-SNARKs example, we can do homomorphic encryption, so you can chain together more certificates into one single big integer number, and do much more than what you would do with regular certificates. Then third point, we can do what we call modern cryptography, so elliptic curve pairing, elliptic curve Diffie-Hellman. We can do hashing and signing for most of the blockchains around. We're already working with Bitcoin, Hyperledger, Sawtooth with Cosmos Standard Mint. We have a prototype working with Ethereum as well. So basically, our tool can sign, can do the hashing and sign the blocks that you will need to write when you would write onto a blockchain without using a blockchain client. Okay. At this point, I expect most of the audience to be very confused, because the tool we have is actually a Hydra with 3 heads. But as soon as I do my little hands-on demo, things will hopefully become clearer for some of you. A couple of links to those of you who want to play with it. Well, our tool is released already. We released the first version around a year ago, actually. We are these days finalizing our long-term support LTS version. We are actually finalizing the language as we speak. The documentation is a little bit behind, but we're working on it. Anyway, the homepage is zenroom.org. Here, dev.zenroom.org, you find the documentation. We're gonna look at the web-based demo in a second, and those of you who want to chat with us on Telegram, it's like t.me/zenroom, and you find us here. Okay, that was our super quick presentation. Now I'm gonna jump onto the web-based demo, because as soon as I run a couple of scripts, you will have a much better understanding of what a tool does. So I'm gonna close this now, and I'm gonna go to dev.zenroom.org/demo. All right. This is also something we are revamping. So if you come back in a couple of weeks, you'll see something completely different. Anyway, you see a web mask here where you can select examples from a list. Let's pick the generate keeper example. So when I click on it, it is going to populate this text field under the Zencode tab. This is, let me zoom it. This is what we call a smart contract, because whatever this smart contract produces, it will give exactly the same result, no matter on what platform I'm using it. So this web demo, it runs entirely in the browser, meaning that the script is passed to a version of Zenroom compiled into WASM, then runs in my browser right now. Let's have a look at the smart contract for a second. It's only 4 lines. Here I define if I want to use a subset of the Zencode scripting language. In this case, I'm just gonna use the basic scenario, which is simple. And here you read the next 3 lines, you see highlighted the word they begin with, which is given when then. Without getting too much into details, the execution of the script is separated into 3 different phases. The given phase is the moment when the data is being read. The when phase is the moment when the data is being manipulated. So the business logic and or the cryptography should be here. And the then data is the moment when data is being formatted and output into something that we can use. In order to run the smart contract, I'm going to press the run button here, and magically down here something happens, and what I get is a key pair. Is a key pair. When I click on logs, I see the specification. We use the Goldilocks curves, but other curves are available to do the same kind of functionality. So let's say I want to generate a key pair that, with a private key and a public key, that I can use to encrypt stuff. If I generate the key pair here in the browser, passing it a certain seed or a certain salt that I am actually allowed to do, the output would be exactly the same as I do, as if I work in a mobile application. Why is this important? Because when you work with cryptography and when you work with blockchain, you need to be 100% sure that the same smart contract would yield the same result no matter who runs it. Well, to give a very, very simple example, if I want to run a Bitcoin transaction, and let's say I want to transfer 1 Bitcoin, one Bitcoin is a lot of money. Let's say I want to transfer 0.01 Bitcoin to someone. In order to do that, I would have to run an algorithm that proves that all the data I have is correct. I would send out the result to the network, and I need to have 6 acknowledgements that the execution of the smart contract is correct. If my execution doesn't match that of the rest of the network, my block will be discarded and the transaction wouldn't go through. For this reason, it's extremely important when you work with cryptography in general, but particularly when you work on blockchain, that the output is completely independent of the platform you run it on.
1 minute.
Okay. Just run one more smart contract, one that is a little bit more complex, encrypt a message for public key recipient. So here we have a couple more lines, and we have 2 parameters being passed, keys and data. So the smart contract goes, given that I am known as Alice, and I have my valid key pair, and I have a public key from Bob, when I write string, this is my secret message, which could be hello world, in message, and I write string, this is the header, hello everyone, in header, and I encrypt the message for Bob, then print the secret message. So here, with those 2 lines, I'm just filling a variable. Here I do some encryption, and here the data is formatted as in a JSON file. And here you find the public key of Bob in data. In keys, you find the key pair of Alice, private key, and further down here, you have public key. Unfortunately, this is not prettified as JSON, it looks pretty ugly. But when I run it, I get the encryption of the 2 lines I wrote here. And if we had enough time, I would show you that I can decrypt this using Alice private key. And I believe that I'm done.
Okay. Thank you so much for your talk. Very technical, but we enter in deep after the previous presentation of the technicalities and how it is possible to migrate from the English natural language to the smart contract easily. So question after. So now we have a presentation by Luca Cervone, and I leave the floor directly to him. Please take the floor and share the screen.
Hi, good afternoon to everyone. I'll try to share my screen that you can see it. I am Luca Cervone. I am I'm showing you something called the Intelligible Contract. That is a project that we built together with the Legal Blockchain Lab and our academic spin-off, that is BitNomos. So I will go very quickly on this, because everybody of us know that current blockchains are able to execute smart contracts, and there are a lot of blockchains that execute smart contracts. The most important one, the most famous one, is Ethereum, and Ethereum was also the first blockchain in the history of blockchains that was able to execute a smart contract. Smart contracts. What are smart contracts? They are small procedures, small software that can execute automatically some simple legal terms of a contract, but they still fails to execute complex features of traditional legal contracts, like recessions, retroactivity, modifications, exceptions, and so on. Also, one of the most important things of legal digital contracts is the legal prose, and the legal prose is something that must be preserved in order to ensure the intelligibility of the contract to humans, by humans. Okay. So actually, there are some regulations worldwide that are trying to give a legal validity to smart contracts. Most important ones are the UNCITRAL Act, the EIDAS EU regulations, the WETA Act, and so on. But there are still some open questions. For example, the territoriality and the jurisdictions of the smart contracts, where the smart contracts are executed, the liability, the enforceability, and the data protections, and so on. So, given if a smart contract can be considered as a specific expression or an interpretation and a translation, mostly a codification of the legal process of the contract, so we can say that the smart contract actually, we cannot see the smart contract, as a single document, but a contract can be seen as a process where you have to identify the parties, you have to understand that there are documents written in legal prose that describe that process, and that that contract will be executed in a specific legal context, and also if the contract is connected to some operational code on the blockchains, then you have an executions, and you have to have reports of that executions, of those executions. So the smart contract supply some of these aspects of the contract seen as a process. For example, the identification of the document, but the identification of the fact that there is a document that we can see as a smart contract, but fails to supply the other needed features of the processes. For example, this is pretty understandable if we see two smart contracts, two Ethereum smart contracts. The one that represents the ERC20 fungible tokens that Biagio showed us before, and the other one is the ERC 721 non-fungible tokens. That is a kind of smart contracts that is used to represent the property of single items. For example, an house, a game item, a car, and so on. And as you can see, so if you are a developer, you can see that these are smart contracts. But of course, if you're a legal person that does not know about smart contracts, you cannot understand what is written in these contracts, okay? So the first thing is the form in which the contract is written. Smart contracts are not written in a human understandable language. And another example is the execution of an Ethereum smart contracts. When a part of a smart contract is executed, this is all that you can see, that you can read somewhere where there are the reports of the transactions of the blockchains, and all things that you can see are hashes. And of course, if you're a judge that have to understand if there were problems with the execution of smart contracts, you cannot understand immediately what happened by just reading this kind of hashes. Okay, so there were already experiments that were used to try to fulfill the gap between the legal digital contract written in legal prose and the operational code that is stored on the blockchain. The first one is the Ricardian contracts. Ricardian contracts are actually can be described actually as triples, where there is on one side the legal prose, on the other side the operational code that is stored on the blockchains, and in the middle there is this a set of parameters that are able to link the legal prose to the operational codes. However, Ricardian contracts are just a theoretical work, and so there are a lot of implementation of Ricardian contracts. The most important one is the smart contract templates that adds something to Ricardian contracts to make this kind of contracts more intelligible to humans. Mostly, smart contract templates say that there should be legal drafting tools that must allow developers and legal experts to create smart contract templates, and the legal prose must be serialized in a standard and flexible vocabularies. For example, XML vocabularies dedicated to the representation of legal contracts, and so on. But actually, there are still something missing, because smart contracts templates are useful to fulfill the problem of the identification of the smart contracts and the problem of documents of smart contracts, because in Ricardian contracts and in smart contracts template, you actually have documents that are written in legal prose, but still they fail to link the context, the legal context of smart contracts under which the smart contracts are executed, and also the executions of smart contracts are still translated into hashes, so into transactions that are stored on the blockchains and that are really not intelligible for human beings. Okay, so we created the intelligible contract. Intelligible contracts are legal contracts written in natural language that can be mapped entirely or partially to operational code that is living on blockchains. And intelligible contracts extend Ricardian contracts and smart contract templates by supplying a specification mostly for the intelligibility of the digital contracts and for the intelligibility of all the process, all the contractual process. Okay. So by doing so, we fulfill all the four mandatory requirements that we have specified for digital contractual processes. Sorry, and also intelligible contracts are a theoretical work. I will go very fast here. I will not explain everything. However, intelligible contracts specify that an intelligible contract must have 5 components, okay, And so you they are an open source theoretical specification, and everyone can create a specific implementation of intelligible contracts. Then, after having done that, we created a scenario, and we identified this scenario that is particularly interesting for us, that is the data processing agreement. Data processing agreement are very complex contract where an agent that owns data of users can give this data of those users to third parties, but this thing must be done under, of course, under the European law, mostly under the GDPR regulation. Okay, so as you can see, you have the data processing agreement written in natural language on the left side, and then we serialize this agreement in a specific XML standard that is called a commentoso. That is a standard used worldwide to serialize legal resources, mostly acts and bills and debates records and so on. We attempted to use it successfully, I have to say, for contracts. And then we have another standard, another XML standard that is a legal rule ML that is also as a commentoso. It is also an OASIS international standard that is used to translate the logical rules of the contract into statements that links the clauses that are in the smart contract, that are in the digital legal contract, to the smart contract that is stored on the blockchain. Another thing that legal rule ML can do, but this will be done later in our project, is to understand if the contract, to automatically understand if the contract is fulfills the laws and the regulations of Europe or other countries and so on. And also, after having do that, you can also create a human readable and explainable representation of what happened during the execution of that contract. Okay. So, as I said, for the implementation of the contract for this specific implementation of the intelligible contracts, we use the Commendoso, also known as legal.ml standard, the legal rule ML standard. We use the Ethereum blockchain for our smart contracts, and also we use this thing called EPLD, the interplanetary link and data, and DPFS, so the interplanetary file system, to store our documents, or at least the documents that can be public. You can see the architecture here. You have this party 2, the digital identity of this party 2, and we have to evaluate if this party can be eligible to use a specific application, a specific web application. So you have an Hyperledger private blockchain where you have the data of the user, this party 2 user, and then you have a third-party online service that stores the legal rule ML, that understand what are the smart contracts that must be executed in order to understand what are the if this party 2 is eligible to use that application. And then you have the party 1 database where you have legal contract, the legal contract, and the other related documents to the legal contracts. And this can be open or not open, depending on the business model of the party 1. And then on the PFS, that is an immutable file system, we have all the act and all the public regulations that, of course, can and should be public for everyone. I'll go very fast here. Okay, this is another representation of that architecture that I show you. here you can see how you can link the GDPR to our contract. So as soon as the GDPR, for example, as soon as the GDPR changes, so is amended, the contract or the database where the contract or the blockchain where the contract is stored can be notified, and so immediately all the contracts that are connected to the GDPR can be updated, or at least the people that have written that contracts and the parties involved in that contracts can be updated, and they can see that, for instance, the contracts not fulfills the requirements of the GDPR anymore. You can see, I'll show you how we have serialized the data processing agreement into a Commentoso. For example, here we have the recitals of the contract that are serialized in a Commentoso, as you can see here. And then
1 minute, Luca.
Okay, and then this as you can see, this ACRF here, this links to a manifestation of the GDPR that is stored on the PFS. This is the same thing. And then we have this thing also for the other legal references or other document related. And then also this is the serialization in legal rule ML of the logic legal rules that are written inside the contracts. You have everything of these is encoded in EPFS hash, and then you can see here that when you have inside the contract, the Commentoso version of the contract, you have a reference to each execution of the contracts that were made by means of smart contracts that are stored on the blockchain. The last thing this is by starting by this implementation, we at BitNomos are implementing the intelligible suite. Note that we didn't use the term contracts because we understood that these intelligible techniques and these intelligible contracts can be used also for other things, for example, for certification that are intended to certify that you own a specific items, for example, as I said before, an home or a game item. And we are defining our scheduling for implementing the intelligible suite, but I think that in a matter of 6 months, we will have the very first implementation of the intelligible suite. There are some references if you want to go further, kind of things. And thank you.
Thank you very much. I know that is quite difficult to grasp any detail, but in this case, we combine legal contract requirements, understandable, transparent, with the persistent and archiving requirements with the smart contract coding. So we want to see the next year some concrete example. So now we have Alex Puig. Thank you so much for coming from Caelum. It's correct? More or less? Yes.
More or less. Caelum Labs.
Okay. Yes. So please go ahead with your presentation. We are very happy to host in this workshop.
Thank you very much. Thank you for having me here. Today I'm going to speak about self-sovereign identity. I'm not sure if you are a little familiar with that. Let me start the presentation. Yes. So can everybody see my presentation? I hope you can see it now.
Yes.
Great, thank you. So basically, a little bit about myself. So I've been involved in blockchain for the last 8 years now. So I'm the founder of Alastrio in Spain. So that's a big association with more than 500 companies with just like one mission, that was to provide with a public service that was a blockchain for identity, for digital identity. Also, I'm part of Next Generation Internet. I'm at INATBA, co-chair for the digital identity working group. So as you can see, I have many hats and I have many identities, and probably that's what this talk is about a little bit. So, because one of the things that I found out in the last few years, like while working with digital identities, that we have too many, but in reality, we have none. So we don't control any of these identities. So we have no control. We have too many of them. As probably you can start imagining right now, you have your identity of Facebook, Gmail, Twitter, Instagram, but not just that. Your public administration has like your national ID, your tax ID. So yeah, there are really literally hundreds of identities, but we are not ever the owners of that. So we have no control on the data that's being used on those identities. Of course, as you perfectly know, the GDPR that's trying to solve that problem. But then from the technology stack, that's something that we're trying to achieve with what we call self-sovereign identity, okay? One of the biggest problem that we see with how digital identity is being used right now is that it's centralized, meaning that it's creating silos of information where there's a big incentive for any hacker to just go there and try to steal as many emails or identities as possible, because then they can make a lot of money. So we are proposing to decentralize that. Instead of having these big databases with thousands of identities, why each one of us as individual, but also as an entity, as an organization, or even last year we did the identity of a car. So we have full control on all of our identities. Through this, the marketplace for data from users, it's growing, it's getting crazy. And some of the things, like on average, we look at our phone 250 or 300 times a day. That's probably, you know that. But then your mobile phone is sending tracking information about you every 15 minutes. And there are a few studies that they show that between 75 or 80% of the traffic from your phone to internet, basically just tracking of your information. So that's what they call the economy of attention. You already know that. But then even so, the price of your data for each one of the users, it's $5 a year, not that much. But if you have information about millions of users, that's a lot of money that people can make. And privacy, it was like for first time, privacy was defined in 1890 by Samuel Warren and Louis Brandeis. It's like the right to privacy. And it was also due to a technological breakthrough, and it was the digital camera. So it was because of the digital camera, the analogical camera. So because of having a photograph, the first camera of taking pictures, they came up with this idea of privacy as like the right to be left alone, the right to privacy. And it's because like they didn't want to have pictures of them owned by others. And it's been like more than 130 years, and we are exactly in the same situation. There's a lot of people with information on us that we have no control on. And it's so crazy that there's a few applications that you can take a look that they will show you who's tracking your information. I did that, and I just found out that the calculator from my mobile phone was sharing information, like my GPS information. As you can imagine, like most of these applications, they don't need this data about me. They just sell it. They just use it, mix it, and share it, and sell it to third parties. So what we are working on, and this is what I'm going to talk about right now. It's practical because we are using it right now. So the tech stack is fully developed, and we already have a few clients working with it. And we are decentralizing digital identity. It's what they call self-sovereign identity. The full idea is, instead of thousands of identities, why don't we have just one, and we have full control on that? So imagine that every interaction that you have with even like with a hospital, with your city, with the company you work on, all of these relations, they generate information, but you store that information instead of this information being owned by others. So one of the good things is that all of this information, it's always digitally signed, meaning that you can prove that information to a third party. So if I go to the doctor and they say that I'm COVID-19 free, then I get a certificate signed by the doctor, and then I can prove that to third parties. Okay, that's also something that probably we should discuss more, because we've been collaborating with the government here on those kind of applications, and we have a lot of concerns when it comes to privacy. So, but we're working, as I say, like an open source middleware to be able to control your identity. Okay. Also, we are working on consent receipts. So imagine, like, every time that you do anything on internet, you get the consent receipt as a company or as an individual. It's like every interaction goes with my consent, and this consent generates a receipt. The same way, if I buy a coffee, I get the ticket for the coffee. So if I share my information with the company, I get this ticket from the company where exactly they say, okay, this is the information you gave us, and this is how we are going to use it. So basically, by using this, they can comply with GDPR by default. Anyway, we designed the platform to be like with privacy by design. We're using zero knowledge proof. As you already, I think it was Andrea that he was speaking about zero knowledge proof. We are using the same technology. So we are using Zenroom. Yeah, we're using Zenroom. So it's quite an amazing technology, and we are using also in our platform. Okay, and the basics of this technology, it's like identity containers. Now we just renamed it. It's like we call them ID spaces, and this is what I'm gonna share with you. But then this is the big change. Like we go from silos to containers. We go from identity to identifiers. And that's quite important, because like we are not creating identity for anyone. So we are not a national identity number or whatever like that. Okay. And then we go from identity access management to verifiable credential access management. And meaning that we are creating processes between companies, and when we send a process to another company, instead of saying, okay, I want Alex, that's the CTO, to sign this budget, it's like we send it to the CTO, whoever it is. So we can preserve the privacy of the people working at companies by working with just these verifiable credentials. Okay. And also we move from client server, where all of the information, it goes always through a central node. Like even with Gmail, all of the information first goes to Google and then reaches the other side. So basically, we're working with peer-to-peer channels. So all of the processes, information or sharing of information between companies, it goes directly and is encrypted between peer-to-peer. And we're trying to move from a world where there's no privacy at all to a zero knowledge proof based world, where I can prove a lot of things about me, but I don't need to share information. I can prove that I'm over 18, that I live in a city, but not just that. Like, most of our clients are companies that they want to prove that they are incorporated in Barcelona, that they are paying the taxes, that basically it's they are creating trust in them. So companies you can trust, but they don't need to share a lot of information about them. Okay. So what's this personal data server or identity container? So basically, it's just a piece of software that lives on the cloud. You can put it also on premise if you want to, but it's just that. And it's like a digital PO box. So you have to imagine that every time that I want to send any kind of information to a company, but it can be a budget, an invoice, a receipt, an NDA, any kind of legal doc you want to send. So basically you have this, it's not an email. It's just like the identity of the company. I'm sending things to the identity of the company. Then we're working with identifiers, claims, contacts, receipts, and documents. So then this piece of software has the capacity to relate with other pieces of software just like that, peer-to-peer, and be part of processes between them. So basically, we have this like data server. First, we just put an identifier. Once again, these identifiers are W3C standards. So a lot of people is using that. It's getting really a lot of traction lately. And the only thing we use blockchain so far, I would say, is like to link this DID to the public key of this DID. So quite simple at the beginning. And everything we're doing is blockchain agnostic. If someone wants more technical details, I can tell them the blockchains we're working on, but you can work with Ethereum, you can work with a Hyperledger, or even you can work with a Polkadot substrate or any kind of blockchain. So we have these DIDs, and why do you use them? So to attach credentials to it. So once I have this identifier, I can just go to my bank and ask, okay, please, you know that I'm paying my taxes like every month. Please, can you just issue a certificate to me, a credential to me, signed by you, by the bank, saying that yes, I'm paying my taxes? That's what they do. So these verifiable credentials are issued to these identifiers. So just with that, quite easily. I just can prove that I own this credential because I have the public key, and if you know a little bit about public, private and public key encryption, so I can prove that I'm the owner of that DID. We did a prototype, so you could prove that a company in Singapore was incorporated in Singapore, so we could do business from Spain by creating this trust signed by third parties. Okay. What else? To these DIDs, we can add more contacts and receipts. Contacts are other companies, by the way, and receipts is like every time I share my information with someone, I can just put a rule there. So I will give them the receipt that, okay, this is my information. You can use it for this or whatever reason. One of the things we found by using this technology was that a few companies, they decided to not use receipts because they didn't want to have the information. So imagine that I have all of the links, all of the peer-to-peer channels to my clients, but I don't have any information about them. And if I want to send a physical letter, I just use this channel and I ask them, okay, what was your address? I will send the address, they will send me the letter, and they will forget the address. So it's quite easy to be compliant with the regulation and to have a really secure system and protect your information when you're really not storing any kind of information, as you can imagine. Okay, what else? Then the contacts probably is the most useful part of this, because what we're doing is like we're creating peer-to-peer connections between these pieces of software that live on the cloud, the identity containers. So we can create processes where this process basically is something like, okay, I want to ask for a document, and inside of the identity container, I just need to locate the member of that identity container, that's people on my company, that basically they have the role or they have the credential that proves that they can sign that that document. So I can move it to the legal representative, or I can add many different kind of conditions to that signature. So I can put 2 out of 3. I could say like, okay, this they need to sign it from legal, then from risk, and then finally the CTO. So it's quite flexible in that sense, because we wanted to have like as many different processes as possible, and all of the time, like the process is just like that. Verifying credentials, like verifying that your company is incorporated, verifying that I'm speaking with the right person, verifying that you have whatever title you need to have or role in the company you need to have, and then using these channels to send and receive documents in a really secure, encrypted way. So secure that basically if I send a document to the CTO, they will receive it, but not even the company will be able to decrypt that. So it's really safe. And also the channels can be revoked. And of course, as you can imagine, like all of the credentials should be revoked too, if needed. Okay. So when we started working with the documents, and then it's like your real digital PO box. And when I started with this, I thought to myself that it was the box that I have at home with a lot of invoices and warranties and tickets and everything else. So it was like that, but like on a digital format, and well organized inside of this box. Okay, but then I can add these docs inside of many kind of processes. Okay, I'm not sure about the time, Monica.
We want to open to the questions.
Great, I'm almost there. So basically, then we are creating a system for decentralized HR where you can have these processes, and there's many capacities, and it's really flexible when it comes to the potential of what we are doing. But at the end of the day, we're decentralizing process. So imagine that's the last example I will give. That I have a fine from my city, so the city will send the fine to me. I will send this fine signed by the city to the bank. They will send me another certificate saying, okay, yes, they pay, so I will send it to the city, and then that's it. Meaning that instead of connecting the technologies of the city and the bank, then by going through me first, everything goes with my consent, and I have full control on everything that's happening, and I get all of the information. But then also the bank and the city, they benefit from being able to just put technology that helps me, their user, instead of trying to connect with all of the different systems that basically they are centralized and they don't scale. Okay, I don't know if that makes a lot of sense, but that's it. So
Thank you so much. And now we can open to the questions from the floor. So people, please, now is your turn to make a question to the panelist.
Maybe we're really good. We did so great job that nobody has questions.
No. So I think there are plenty of questions. I can see the questions in any case, probably the moderation. How many companies, gov institutions use verifiable credentials? It's for you, Alex.
I know, a lot of them. So basically, it's a standard by the W3C. So DIDs and verifiable credentials, like everybody's using that. Even all of our competitors, everybody working with self-sovereign identity all around the world. So there are many projects, I would say, like in the States, in Germany, in Australia, in Canada. So a lot of them, they are using the same standard. Like the full idea is that they are interoperable. So no matter which technology creates issues these credentials, everybody should be able to read them. So you are not vendor locked in that sense.
Okay, thank you. And there is a valuable question from Robert Kowalski. Thank you. Bye. I'm very happy to have you in the workshop concerning the natural language translated in legal ReMeP. So it's for me, the question depends to the language, first of all. In English, we are developing as a University of Bologna some tools for extracting ontologies from the text, NER position, so entity position inside of a language, like actor, roles, dates, action, and to combine in order to understand the meaning of the relationship among those parts of the language. And secondly, we use argumentation schema of Walton in order to apply sentiment analysis of the text and to detect arguments and then to try to detect obligation, permission, prohibition, and violation in the text. But from our experience nowadays, we can detect simply portion of the text and to help people with a web editor interface in order to complete the legal analysis in legal ReMeP. At the end of the month, I have a talk in a ReMeP conference, and I can explain that. Other questions?
Answer the question that was about the game in the chat, but that's...
Yeah, please, Biagio, answer to the question concerning the previous. Probably there is some people that ask concerning if some players vote against the beer, what happened?
Yes, I shared the link of the transaction on Etiscan, and I can show you a screenshot of the chat in that occurrence. Of course, I censored the name of reasons. So there it is. This is what happens, basically. I don't know if you can see it on the screen. The sentence is auto-executed, the verdict is not guilty, and the transaction, the stake is simply removed from the state of the smart contract. And that's it. It's really that simple.
Thank you. So jumping again to Robert that asked if the control natural language technique can be helpful to do so in terms of translation. So control natural language techniques, it's good for the first paraphrases, but time to time we have, especially in the European legislation, some exception of exception and some derogation of the derogation with temporal suspension of the norms, and a simplification of the language is not good for detecting a valuable part of those situations. So in our experience, to simplify too much the controlled language means to delete some valuable legal knowledge that the legal expert needs to know in order to model in a correct manner the rules at the hand. Otherwise, it's a super simplification of the norms, and in some situation is not appropriate applicable. So these are our experiences. So for this reason, we apply machine learning for extracting valuable part of the speech, entity recognition, POS part of the speech recognition, and sentiment analysis in order to detect arguments. And we push everything in the portal of the web, close to the text, and with some parts we do so. So especially this is especially written by the lawyers, it's difficult. But I can probably show you let me. We have a tool for do so in our university. We produced a tool for help the people in this job. Let me share the screen in order to show. This is a Rave editors. In one side, I have a serialized in a command also. In this case, I have a piece of legislation, and in the rest of the rules, I have the possibility to open and model in blocks the rules and to connect the semantic parts detected automatically by machine learning or parsing or natural language in order to connect the rules directly with the ontologies in the legal rule ML parts. And so we help as much as possible the serialization automatically with the help of the people, legal expert, in order to complete the legal reserialization and modeling. This is our approach. So so this approach is good also for smart contract because, as Andrea said before, we have a great attention nowadays in Europe, especially in the European blockchain infrastructure, to have common ontologies. So common ontologies, it's a great part of the planning in the European blockchain infrastructure in order to talk about the same things with the same predicates and same name inside of the smart contract. This is another very important topic in the agenda of the smart contract and blockchain nowadays. Other questions? So, Suzanne, thank you so much for recalling me the fact that now we have the network break, but you can continue to put the question here, maybe, and we can answer later on. Now there is a break till the 4:45, and that's it. So we have the room for the last question. So conclusion is that we are ready for new application, not limited to financial domain, in privacy, in identification management, in the contracts, in the legal documentation, in governance, voting, and also social governance of debates, like Biagio demonstrated. So we can start with optimism in order to have those applications beyond the financial topic. Okay, thank you so much to everybody. Thank you.
Thank you
Thank you, Alex.
Thank you.
Biagio, Luca, thank you so much, and see you soon in the next panel or in the... Bye.
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 Bye.